Hey guys, welcome to Phys Science. In this video we'll be doing projectile motion problems for a question paper of 2021 November. (3.1) Is the hot air balloon in free fall? Choose from yes or no. First of all, we know that free fall is defined as a motion of an object under which the only force acting on it is the force of gravity. So if we check this balloon, it is going upward and gravity forces everything to go downward, meaning this balloon is going by an engine force. So gravity is not the force that causes it to move. So the answer will be no. Answer will be no. Then you have to state the reason. Reason says gravity is not the only force acting on the balloon. So let's check the statement now, what it says. When the balloon is 200 meters above the ground, a small stone A is dropped from the balloon. See the diagram above. Okay, another small stone B is dropped 5 seconds later from the balloon, while the balloon is still moving upward as the constant velocity. Okay, let's draw our scenario. We have a balloon. We have a balloon which is moving upward. So they say now this balloon, it is 200 meters above the ground. What happens if the balloon is 2 meters above the ground? A stone A, they say there is a stone named A, it is dropped from the balloon. So it is dropped from the balloon, which means it will go down. And then they say another stone B is dropped 5 seconds later. Okay, let's just draw it here. Stone B is also dropped 5 seconds later. Okay guys, before attempting question, what you must understand about a moving hot air balloon is that if a balloon moves up with a certain velocity, all the objects inside that balloon, they are sharing that same velocity. Meaning, if this balloon is moving with 4 meters per second, ball A is also moving with 4 meters per second. Even ball B, before being released, is moving with that same 4 meters per second. So for him, it means that the balloon, it's moving with a certain velocity, which we are not given. And also ball B is moving with a certain velocity. But immediately after ball B is dropped, ball B will have this velocity of the balloon. For example, it will have 4, then minus or plus, depending on whether ball A or stone A will be going. So since for this one, it is going downward. If we're having 4 meters for the balloon, it was going to be 4 meters minus 0, since it is dropped going down. So for this situation, which means the velocity of the balloon is equal to the velocity of the stone. Why? Because velocity of the balloon minus 0 does not make a difference. So which means the balloon and the stone A, they share the same velocity. Which means if I say initial velocity of stone A, I also mean initial velocity of the balloon. They are equivalent. And we are given the final velocity of stone A, which is equal to 62.68, but the stone was going downward, and we know that we always choose upward as positive and downward as negative. So the velocity of VF of stone A will be negative 62.68 meters per second. And the acceleration, we know it is always negative 9.8 meters per square second. So the first question says that we must calculate the speed of the hot air balloon. And now we understand that the hot air balloon and the stone A, they are sharing their velocity. So which means by us calculating V initial of stone A, we automatically have calculated the speed of the hot air balloon. So first thing first, 3.2.1, we collect our data for stone A. What are we given for stone A? Stone A, V initially, we are not given. It is what we are looking for. V final, we are given as negative 62.68 meters per second. What about acceleration? It is a constant, negative 9.8 meters per square second. Then what about displacement? Displacement, will it be change in X or change in Y? It will be change in Y because stone A is moving vertically, up to down. It is a vertical. So stone A was moving up and going down, which means it is going in a negative direction. Our change in Y, since we were given that it was thrown from 200 meters above, it will be negative 200 meters. So by this data that we have to calculate V initial. Hence, we will use the kinematics equation or the equation of motion. We will choose our second equation of motion, which says Vf square is equal to Vi square plus 2a change in X. Vf square, we have negative 62.68 U square equal to V initial is what we are looking for, plus 2 into negative 9.8. Then change in X or change in Y, because here we are dealing with a vertical motion. It will be negative 200. So you press your calculator on the left hand side and on the right hand side. On the left hand side, you will have 3,928.78 Vi square. Then 2 into negative 9.8 into negative 200. It will give you plus 3,920. We have to solve for Vi. We take Vi square, we make it the subject of the formula, which means we'll take 3,920 and minus to the other side. Which will give us 8.78. But we don't want Vi squared, we want Vi. So we'll introduce square root both sides. So Vi will be equal to the square root of 8.78, which is equal to 2.963 meters per second. So this is the initial speed of the ball, which is equivalent to the same speed that the balloon was moving with upward. So let's go to 3.2.3. The question says that calculate the distance between the hot air balloon and stone B at the instant when stone A strikes the ground. So what you have to do here, you have to collect the data first. So we'll collect the data for stone B. You know that stone A and stone B, they were both in that balloon, and the balloon, it says that it moved with a constant speed, which we calculated to be 2.93, meaning also the initial velocity for stone B, it will be 2.96. But will it be positive or negative? It will be positive, because after it being released or after it being dropped, it will first go upward, then gravity pull it down. So we will have positive 2.96 meters per second. acceleration is a constant, negative 9.8 meters per second. What about change in time? So change in time, change means final minus initial. So we will have our final time minus initial time. What will be our final time? Since ball A and ball B were dropped in a height of 200 meters, we assume that they will reach the ground with the same time. Which same time? The same time which we have calculated for stone A, which is 6.7. But what about the initial time? The initial time, it is said that ball B, it is dropped after 5 seconds, which means the initial time for ball B will be 5 seconds, which will give us 1.7 seconds. So what about change in y, the displacement? We don't have. So which equation of motion that accommodate all of this data? So we'll use our third equation of motion, which say delta y is equal to initial velocity multiplied by delta t plus a half of acceleration multiplied by delta t square. So we substitute what we have. Delta y, we don't have. The initial velocity, we say it is 2.96. Our delta t, it will be 1.7 plus 1 all over 2 into negative 9.8. Then we put our delta t and we square it as the formula is raised to the power 2. Then now you have to press your calculator, which will give us negative 9.129 meters, which we can say it is 9.13 meters downward. So this is the distance that will have been traveled by stone B when stone A strike the ground. But the question says we must get a distance between the hot air balloon and the stone B, which means we must also calculate the distance that will have been traveled by the balloon when stone A reaches the ground, because as the stone goes down, the balloon continues to go up. So we will also write data for our balloon. We know that our balloon was moving with a constant velocity, which is 2.96 meters per second upward, and its acceleration, be careful on this one, the acceleration will not be negative 9.8. Why? Because acceleration refers to change in velocity, and it is said that the balloon was moving constant. There was no change in the velocity, meaning the acceleration is 0 meters per squared second. Change in time, we still use 6.7 minus 5 seconds, because we are focusing to stone B now. Then change in y is what we have to calculate for again. So again, we will put our equation of motion that says change in y or change in x is equal to initial velocity multiplied by time and a half of acceleration multiplied by a squared delta t. So initial velocity, again we put 2.96, our change in time 1.7 plus 1 all over 2, acceleration now it's 0, change in time 1.7. Automatically when we include 0, all of these become 0. So press your calculator to get the other side. So 2.96 multiplied by 1.7, it will simply give you 5.032 meters. So what do you have to do now? So to get the distance between the hot air balloon and stone beam when A strike the ground. You have to use this distance that you got by using the details of the balloon and the distance that you got by using the details of beam. So you can simply say change in Y, which is needed by the question, is equal to, we will say change in Y is equal to Y final minus Y initial. So our Y final will be negative 9,13 minus 5,032. Then you press your calculator, which will give you negative 14,16 meters. And we know negative is just a direction. So the final answer for this question will be 14,16 meters downward. But to avoid the confusion when you reach on this final step, you just take this 9,13 and add it with this 5,032 and you will get your 14,16 meters downwards, which is your final answer.